Hello everyone, today I am here to give demonstration on projectile motion using VPython, and this line gives me the module for this program. After considering the basic things for projectile motion like acceleration due to gravity, mass, initial velocity time, and this is the number of time the readings were the number of times our motion is divided into, maximum height, theta, which is the angle at which the projectile is carried out, and dt, which is change in time. Let's assume the ball with the following physical properties, and we know that the maximum height of the projectile motion is calculated by using the formula u square into sine theta whole square divided by 2 into z, and we just did a pi by 180 and multiplied it with theta just to convert it to the radian. So now let's look at some of the calculations. Del v, which is the change in velocity. As we can see that there is just the change in velocity in y component, since the x component of the projectile motion does not change. The velocity of x component of the projectile motion remains constant, so it's 0. The velocity of y component changes by g into dt, and the z component is 0. So the vector for the velocity of x component is u into cos theta, for y component is u into sine theta, and for z component it's 0. And now let us look at the loop. N equals to n plus 1 is just keeping the count of number of times the loop is running, which means that it shows that how many the projectile motion is divided into how many fractions while taking the each reading. So v equals to v plus del v. What it is doing is that it's updating the value of change in velocity. As we know that the y component of the projectile motion is changing, so it's just updating the value. And we have ball position equals to plus or equals to, sign means ball position plus, this means that ball position is equal to ball position plus v into dt, which gives us that this was the initial velocity, and after this, by multiplying the velocity with the change in time, it's helping us to give the new position of the ball. So it's like updating the position of the ball as the motion is going on. So now for the maximum height, we just compare it with the each height until we get the one which is bigger than until we get the max height which is bigger than the value which we are comparing. What this does is that ultimately it would get one height which is the maximum, and whenever it is compared to any other height, there won't be any value that would be greater than this. So max height would ultimately take the maximum value, and this is how we take the max height. Now if ball dot y is less than 0, which means that if the y component is less than 0, we did this so that the ball wouldn't fall below the ground. We print the position of the ball to be ball pulse, time to be t plus n into dt, which is the initial time times the number of times the motion was divided into change in time, and the maximum height would be max h, which we know we have calculated this by comparing each value in the motion, and this max, the hh, is the actual maximum height, which is calculated by using this formula. Now just let us run the program and see what happens. After running the program, we see the projectile motion at 45 degrees, and we find the position of the ball to be following: time to be 2.88 meters, maximum height to be 10.1, and maximum height, which we calculated using the formula, to be 10.2. The little error in this maximum height might be caused due to the floor, as we know that we didn't position the floor at 10, minus 1 and 0. We didn't do this 0 because we didn't wanted the ball to go look like as if it's going inside the ground, so we kept our ground a little below than the ball. So this have caused a little error, but the value is almost the same. As we can see that it's 10 and 10. So now let's just change the value to 30 degrees, so maximum height should decrease. So let's run this program. Yeah, as we see that the new value, there is maximum height decrease as the theta decrease, and there's less maximum height than 45 degrees. That's all for today. Thank you.